Hey everyone, it's Kenny. Today I'm going to be showing you how to build a multi-AI agent application in Langgraph, and 2025 has definitely been the year of agents. We've not only seen the potential but proven value that AI systems like Claude Code and Manus create, and they're only going to become more capable and prevalent as the models get better. But multi-agent systems are not always the right tool for the job. There are specific use cases where the multi-agent approach is the best and even the only solution to solving a particular problem. So today I want to focus on the supervisor multi-agent design pattern. And if you watch through to the end, you should have a better understanding of when and how to implement this system. And as always, all of the code will be available to you for free at the AI Launchpad Repo, which you can find in the description. This is the system we're going to be building. We're going to have a supervisor where only the supervisor is going to be interacting with us, the user, and the supervisor is going to be managing two other agents, a researcher and a copywriter. Each of these agents has their own set of tools, system prompts, etc. So the context is all split. Our researcher can search the web, it can extract specific raw content from any URL, and also it can generate a research report. That's all saved to the central state managed by the supervisor. And so whatever research reports the researcher generates, those can be shared with our copywriter. And that's just to give factual context, to give grounding facts to the copywriter to create its content. So the copywriter is then going to be able to review the research that's generated and then write specifically optimized LinkedIn posts or blog posts. And in this case, we're keeping it simple with just these two, but you can imagine extending this to add more content sources. But yeah, that's the system. It's pretty simple. Let's hop over to the terminal and go ahead and run this example. So I've kicked the system off, and remember that we're only speaking with the supervisor directly. We're never going to be interacting with the researcher or the copywriter. That's all managed by the supervisor. So if we ask a question that is only related to research, for example, the supervisor will route the request to the researcher and then give us back a response once it gets the output. Let's do an example of just research. What are the top 5 US states by total land area? And we have streaming back tool calls as well as the actual responses from the agents. So what we're seeing here is the supervisor has called this handoff to subagent tool. And let me just scroll up so we can see this. So here's the JSON for that tool call. We have a couple of inputs. One is the agent name, which in this case is the researcher, and then a task description. So the supervisor is asking the researcher to go and research the top 5 US states by total land area in square miles. So notice that our prompt is pretty basic, but it's just adding some more details here to make it more specific. So provide an ordered list with each state's local land area in square miles. Cite authoritative sources like the US Census Bureau or NOAA. So that's cool. And then it gets handed off to the researcher. The researcher then starts to search the web. So it queries US states by land area. And here it's extracting the raw content from this particular web page at census.gov. This just allows it to get the full contents of that web page, because when you just do a web search, you're only getting the preview of the results, right, and a short summary. So it's going to go and dig into that data, and then once it finds the answers that it's looking for, it's going to go ahead and call the generate research report tool. That's going to allow it to save it locally. Here's our researcher responding in markdown format with a summary. So this is the report it generated, and then notice at the bottom we have our citations here. So this is all in the system prompt, and we should be able to go to this, and this should be a real website, hopefully. It's not hallucinating. So yeah, here's the census data, And here is a table of all of the land area. So if we look here, Alaska is the number one with 570,000 square miles. So we should see that in the table. Here's Alaska. And total land area, this is minus water, so it's broken out by water and land. So we can see it is 570,000 square miles. So this is all grounded in real data. The reason why this is important is if you were to write a piece of content, especially something that has to do with, for example, news, if it's like AI news that you're reporting on, then you want everything to be grounded in facts, right? You don't want it to just make stuff up. So it's important to have this type of citation creation for any reports you generate. But yeah, that's the research report that we get back. And then the supervisor is just going to see the output here and then just summarize the findings for us. Now, the point of this system overall is to eventually write content. So we want the supervisor to handle the research tasks in finding whatever information it needs, generating reports through the researcher to then feed into the copywriter so the copywriter can write really high quality content backed up by real sources. So now let's test that out with a different prompt. I copied over a prompt that I've been playing with, and I'll show you. This is in the repo, so you can play around with it yourself too. We're asking it to write a LinkedIn post on the top AI tools that small businesses and entrepreneurs need to be using to scale their businesses. Include real-world examples and case studies where the businesses are using these tools to scale their business with real numbers. Include a call to action at the end for readers to follow me for more actionable playbooks on how to generate value for their business. So this is a really nice specific prompt that should take advantage of the whole system. So the first thing the supervisor does is hand off a research task. And you can see it's also called this research task number 1. So the supervisor is prompted in the system prompt to break out more complex tasks into more concrete and specific research subtasks. So in this case, it's kicking off one research task. The researcher is just going to focus on this one task until the supervisor asks for a follow-up or to move on to the next research task. And this time we're getting multiple queries. So it's searching the web using different queries to kind of take different angles on this research task. It's looking for top AI tools for small businesses in marketing, sales, customer support, etc. And then it's gone ahead and generated that first report. So here the researcher is saying, I researched and prepared a 12-item list of AI SaaS apps useful to small businesses across marketing, sales, support, operations. Okay, cool. Here we see another handoff. So after the researcher is done, this goes back to the supervisor. So remember in the first example, the supervisor summarized the research report from the researcher. So in this case, the supervisor wants to move on to task number 2. And so it's going to call the same handoff tool to go back to the researcher, but now focusing on a different task. So the first one was specifically searching for tools. This one is find real world use cases. So now it's moving on to finding case studies where we can get real numbers of how these tools benefit small businesses and entrepreneurs. So again, the researcher will go and start querying a bunch of things. This one is actually way more comprehensive. So it's searching 5, 6, 7, 8, 9, 10. So I did like 10 different web searches for this one. And then it's gone ahead and generated its second report. Okay, so now we're getting another research task, but I think it's a little confused. So it labeled this one too, even though the last one, it was already called task 2. But this is looking at a different topic. So use a variety of industries and include case studies labeled SMB. Oh no, so it is still research task number 2. It's just asking it to be more specific about looking for small businesses. So it's seen the output of the researcher and decided, okay, this isn't exactly what I was asking for. So it's going ahead and modifying what it wants from the researcher. Again, the researcher goes, generates a report, We get another handoff to the researcher, so it looks like it wasn't happy again. So now it's asking for a more specific task, 6 to 8 case studies, varied industries, SMBs or small market businesses using AI tools to scale. Okay. And then the researcher goes and generates another report. This one does look like it's a lot more comprehensive. So we have a breakdown by these different companies. So these are now very specific case studies. And we're even seeing numbers here, right, which is what we originally asked. So here you can see where the supervisor is steering the outputs of the sub-agents, which is really important in these types of systems. Typically, you're also going to be using a more powerful model for the supervisor. So the sub-agents, they're working on very specifically defined tasks, right? So normally you can get away with using cheaper and less performant models there. But for the supervisor, you generally want to use a pretty good model, and that's how you'll get this kind of course correction. Finally, we get a handoff to the copywriter. So the supervisor finally sees that the researcher produced a satisfactory report for that task 2, and now it's gone ahead and given instructions to the copywriter to write this LinkedIn post, and you can see how detailed this request is. If we keep scrolling down, the copywriter reviewed the research reports available. So all of those reports that the researcher generated were saved to the state. So those are going to be accessible to the copywriter. And then here we go with the generate LinkedIn post. The copywriter then outputs this post here. So let's read this. Here's the hook. If you're a founder still treating AI as nice to have, you're leaving revenue and time on the table. Here's a focus stack that actually moves KPIs and a playbook you can run with this week. Recommended tools and the typical impact. So we get HubSpot, CRM plus AI, ChatGPT. Oh, here we go. So here are the actual measurable outcomes. So we have real world vendor case studies at the bottom here for these specific companies. So here you can see real numbers, which is, going to make the post a lot more compelling if you're backing it up with facts. If we keep scrolling down, we have a 7-day founder playbook. And then here's the call to action that we asked for. Follow me for more actionable playbooks on how to generate real value for your business. So that's really nice. And then the supervisor finally responds, summarizing everything that was done. So this was probably running for 3 to 5 minutes, but I'm actually pretty happy with the LinkedIn post that it came out with. If anything, I would say it should be shorter. It's kind of a long read, maybe shorten like these sections where it's kind of describing what these tools are and keeping it as a short list with these numbers to back it up for the real world use cases. But overall, it's a really nice example of pairing research with content writing. So I think this is a cool example of where a multi-agent supervisor system works. I will say that you could definitely solve this very narrow task of researching a topic and then using it to write a LinkedIn post, right? That's a very specific workflow that you could just build a predefined workflow to solve. But there are pros and cons to using a multi-agent system to solve this kind of problem. And so I want to spend a little more time because I think it's super important to understand what the trade-offs are and when you should think about using an AI workflow versus an AI agent and then even a multi-agent. So here I've kind of summarized it as succinctly as possible, just into like a one-line guideline where when you have a problem that can be solved in a well-defined set of steps, which basically means that you could hard code it. So if you write one function to do one thing and then feed that output to another function, also known as prompt chaining, then you should build an AI workflow to do that because there's a lot of benefits you get from AI workflows. Generally, you always want to solve a problem in the simplest way possible, right? Because that's the fastest path to getting results. Usually it's an easier implementation, so that's going to mean less debugging, easier to manage, and it's easier to optimize that simple workflow. You also get the benefit that it's more deterministic, the solution is repeatable, and generally you're going to have much, much better reliability, which is crucial for production. But if you do have problems that are more open-ended and it's difficult to know beforehand what are all the steps required to solve that problem, in other words, you can't hard code it, then that's where an AI agent makes sense. I think the most common or ubiquitous example of where an AI agent excels is in coding tasks, because in coding, it's not always clear what the next step is going to be, right? You could write a piece of code and then find a bug in it and have to debug it. You could have to search for docs. You could have to write a test and execute that test, or write to a file, read from a file, edit a file. So the set of steps required to solve a particular coding problem is basically infinite. That's a really good example of where an AI agent is required to solve that particular problem. And between these AI workflows and AI agents, I think definitely the best guide, if you haven't already read the blog post from Anthropic on building effective agents, I highly recommend you check that out. And you can also check out the video linked in the description where we built out all of the AI workflows and the AI agent outlined in that blog post in Langgraph. And that project is also in the AI Launchpad repo. Coming back to multi-agents now, if you do have a good problem for an AI agent and that problem is also complex enough that performance with a single agent really starts to bottleneck, either because you have too much context that you're trying to put into the system, but that context is really important and required, but it's just too much for the context window for the agent to perform well, that's a good use case potentially for moving to a multi-agent system, because you can separate context between agents. If you have too many tools for a single agent to handle, another good example of where you might want to move to a multi-agent system. But generally, these are the guidelines I would recommend for choosing between what solution for your problem should be. Now let's quickly touch on why multi-AI agent systems are beneficial for these types of problems. There's 4 main benefits that you get from multi-agent systems over a single agent system. The first is efficiency. Because you're able to have multiple agents potentially working on different aspects of solving a problem in parallel, this greatly reduces the overall latency of your system. And through parallelization, you also have breadth because you're able to cover a lot more ground in a shorter amount of time. So a good example of this is research agents, where you can have a supervisor or manager agent that kicks off research tasks, and you spawn a bunch of research subagents that are all looking into a specific subtopic for the overall research goal. And you would do all of that in parallel and then get back all of the research reports and then synthesize your final output from those individual reports. You also get better context management because you have agents that are working on a specific task rather than trying to cram everything into a single agent. So in the example that we just built, if you crammed in the system prompt, the tools, and all of the research reports, for example, if you crammed all of that for both the research task and content writing into a single agent, you can see how it might be a little bit confusing, because now you're going to have a huge context that's taken up to describe all of the functions and tools. So separating those out keeps your agents more focused and allows you to reduce the amount of distractions that they have, so it's easier for them to focus on one thing. That's going to improve your performance and your reliability. The next one is super important, where we can massively scale our token usage, and that's going to lead to almost a direct linear relationship with performance. There's several studies out there that have shown that the longer or the more reasoning tokens that models are given, the better they are at solving tasks. So here are a couple of charts from a paper, which you can read if you want to by just clicking on the actual image. It's linked to the original paper online. But here you can see how when we increase the number of tokens for thinking, accuracy for these models goes up. And this is true to a certain extent, right? There is this point where too much thinking can actually saturate performance, and after a while it actually can worsen performance, which is also covered in this paper and super interesting. But for the most part, up to a standard amount of thinking, you can get a high improvement in performance if you allow more reasoning tokens for your agents. And the reason why that's important is because we're talking about using multiple agents, which means now we have multiple context windows, and each of those agents has a certain number of reasoning tokens that it can use within its own context window. So we're effectively multiplying the number of reasoning tokens across the entire system versus using one AI agent. So that's what we're talking about here. We have context window multiplication, where basically your context window is just going to scale with the number of agents that you have, and that leads directly into how much work can be done. And then finally, the last one is modularization and reusability. So because we're building these agents out separately and optimizing them for one task, we can ensure that we're using the right model, tools, prompts, etc. for that specific task. And we can also update and optimize those agents independently without affecting the others, which gives you that modularity. And finally, you can reuse these agents. So let's say you have a highly optimized research agent like we're showing here, you could use that across different applications, right? So if you have a content creation system or a competitor analysis system or a customer prospecting system, you could use the same researching agent and maybe only do some minor tweaks, but be able to plug that into your other agent applications as well. So that was a lot of theory. We're done with the theory. We're going to get into the code, but I hope that was useful because I do think it's important to be able to take a step back and understand the trade-offs of different AI solutions and when and why you should use them. Also, a quick plug for the AI Launchpad Repo. All of these reports that I write up, I spend a lot of time on, and I hope they're informative and helpful for you. You can find all of this in the READMEs in the different projects. So don't sleep on the READMEs. Definitely check them out. There's a lot of useful information in there. All right, finally, we're moving on to the coding. So you're going to want to head over to the AI Launchpad repo. And if you're new here, this has all of the code templates, examples, tutorials that we do on this channel. It's linked in the description and it's pretty easy to set up. You only need to set it up once and then you can just pull each time we release a new project and follow along. While you're there, if you don't mind, you can give this repo a star, and why not just like the video at the same time, because it helps out my channel a lot. You're going to want to scroll down. There's a getting started section and it's just 4 easy steps. You're going to want to install UV, which is going to be your Python package manager or Python project manager. Then clone the repo, install the virtual environment and dependencies with one command, UV sync. And then you're going to want to set up your API keys, which for this project only has 2. You need the OpenAI API key and Tavily for web search. So we're going to be working in the Langgraph module today. Let's hop over to the repo, which I have open here. And we're going to go into this new multi-agent folder. And this is the supervisor project that we're going to be working on. So this is what we're going to be building. And I also want to mention that for multi-agents in Langgraph, there's different ways to actually build this out. And this is because Langgraph is a lower level framework than a lot of the other agent frameworks out there. So because it's lower level, you can build the same type of system in different ways. And specifically with multi-agents, I'm talking about using agents or multi-agents that you call from tools versus building an agent system as a graph and then using that as a subgraph in a larger graph to build your multi-agent system. What we're going to do is the latter, because I think there's a lot of examples of calling tools in other projects online as well as this repo. And I think it's important to understand how subgraphs work in Langgraph. I also think for observability, for tracing, it's much better to have the subgraph implementation because you can follow along within each of your subgraphs, all of the node executions, all of the tools that are getting called within those subgraphs, where if, for example, you're calling a sub agent from an MCP tool or some online API, you're not going to get that, right? So if you are building this multi-agent system all kind of in one place together, then I would say you should go with a subgraph approach. I'm going to be assuming that you're somewhat familiar with Langgraph, but this is still a beginner-friendly tutorial. It's just not going to be teaching you everything about Langgraph from the ground up. We're more so going to focus on the specifics of implementing the supervisor multi-agent system. If you are interested in learning Langgraph at a more basic level, introductory level, I have a video on an introduction to Langgraph, which will be linked in the description below. So let's start out with looking at the researcher. We're going to load the system prompt from this prompts folder here. And we have one system prompt for each of our agents. So let's look at the researcher. This is just a markdown file where we're going to explain the role, the tools that are available to this agent, which is search web and extract content from web page. So that's if we want to get that raw content. And then we're going to specify a report format where we want it to give us a topic, which is basically the title of this report, and then the actual report, which should follow a similar structure to this example. And then that's why you saw in the demo that we have this citations section at the bottom in the final report. So that's all in the system prompt. So we're going to load that system prompt first, and then we're going to define our tools. And if you're back from previous videos, then you will have seen this already in our effective agents project, where we have our search web tool using Tavily. And basically here, all we're doing is using the Tavily web search, and we're just going to limit because you get back a lot of fields from this raw search. So we're just going to curate what we're actually giving to the model. So here we're returning a processed results dictionary, which we're just going to have the title, the URL, and then a preview of the content. Then if the agent wants to extract more information, it can get the full raw contents by extracting the content from the web page using also this Tavily extract object. Then we have our research report tool, which is going to return this research report object, and that's going to have a topic and then the report. So that's what you saw in the system prompt. And what I want to focus on for this tool in particular is what we're returning in this command object. So I think this is a newer construct in Langgraph that maybe not a lot of people understand, but we have this command primitive that takes in 4 different input arguments. You have graph, update, resume, and go to, and all of these serve a specific purpose. Graph is just going to be the graph that you want to send the command to. In this case, if you don't put anything, that's just going to be the current graph. Update is going to be a mapping between the state keys for this graph that you want to update and the new values that you want to update. So it's just updating the state. You have go to, which is just going to be a string telling the graph what node we want to go to next from this exact node. So when we call this generate research report tool, where do we want to go after this? And then resume is if we've hit an interrupt in the graph. So if we have human in the loop and we have an interrupt, then we can put a resume value here, and the graph will resume, taking in that value and passing it to another node. So you'll see exactly how this works in this example. Up here, we're just going to take in the topic and report, which is going to be generated by the LLM. And so we want to have a good description of what these are here. And then we're going to create that Pydantic class for the research report, putting in those 2 attributes. And in the researcher state, which we have down here, you can see we just have 2 keys. We have our normal messages key and then a research reports key, which is currently set to an empty list. But this is a list where whenever we make updates to this list with a new research report, we'll just extend this list or append that new research report to this list. So effectively, every time this tool is called, we're just going to be adding the new reports here. Going back up to the Generate Research Report tool, here we have an update dictionary. So for this command object that we're returning, the only input parameter that we're using is update. So we're going to make an update to the state when this tool is called. And we're going to update research reports, which again is this key here in the state. And we're going to pass in this new research report that was just generated by the LLM in this tool. We're also going to update the messages key by adding a new tool message. That tool message is going to be the string representation of that report. So we're just using model dump JSON here. And of course we have to pass in the right tool call ID. Since this tool would have been called with a specific ID, we need to return the same ID in the message. So that's how we're using the command primitive here. Because normally for tools, for basic tools, you just return a string, right? Here you would have some logic to do something. Maybe we call an API, we're getting some data from somewhere, and then we return the results in a string. By using the command primitive, we're actually able to update the state. So that's why it's important here. The rest of this is your standard Langgraph implementation. We're gonna create our tools list and define our LLM, bind the tools, and then we're going to define our main researcher agent node, which is going to have this LLM with tools that we invoke, and we're going to add the system prompt along with all of the messages in the state. Now, if you're wondering why here we're just returning a dictionary and not the command primitive, remember that for nodes in Langgraph, it's always state in and state out. For tools, that's not the case, right? When we call a tool, normally we would just return the results of that tool in the form of a string, and the tool message would get appended with those results. But for a node, we always have state in, state out. And so all we have to do with a node is specify what key we want to update. And so we can return a dictionary that says we want to update messages and add the response from the LLM there. So that's just how Langgraph works. Finally, we have our research router, which is going to be after our research node, and that's just going to check for tool calls and route to the tools node if we do have a tool call. Otherwise, we're going to route to the end. So we build our state graph and then add our researcher node and our tools node, and we're going to add an additional edge from the tools to the researcher. We always want to have this with agents because once a tool is called, we want the agent to be able to review the outputs of that tool to decide what it wants to do next. Finally, here we have our conditional edge, which is just going to be our researcher router that we defined above. So that's the researcher, and you'll notice that when we're running a graph like this, normally we would have a checkpointer like this, and we would specify a checkpointer, usually an in-memory saver. That's going to allow you to have short-term memory where the conversation history is stored in memory. And so every time you invoke the graph, you're going to have the full conversation history between the user and the agent. When we're using a graph as a subgraph, we actually don't need to pass a checkpointer. So I'm just commenting that out and leaving it so that it's clear that we're using it as a subgraph here. And the reason is because as long as the parent graph has a checkpointer, that will get passed through to the subgraphs. So we don't actually need to define it explicitly here. And finally at the bottom, if you want to visualize this, you can uncomment these two lines at the bottom and we can run that. And you can see it's a super simple 2-node graph with our agent and then the tools node. Of course, the tools will have multiple tools in here. The copywriter is actually a bit simpler. Similarly, we're going to load our system prompt, and we're also going to load a couple of markdown files, which are examples for how we want our LinkedIn posts and blog posts to look. I literally generated these examples using ChatGPT. You can find them in this example content folder. So if we just open up blog, here's an example of a blog post, and then looking at LinkedIn. This is an example post, so we're telling it in the system prompt, you should try to write posts that look like this. Now, the copywriter state is also really simple, and it's actually going to be identical to the researcher, although it doesn't have to be, right? That's the beauty of having multiple agents is the state, the prompts, the tools, everything is separate. The reason why we have this shared key is because we actually do want to share the research reports that are generated by the researcher with the copywriter. So this key in particular is going to be shared by all three agents, including the supervisor. And the copywriter is just going to have three simple tools, much simpler than the researcher. We have our review research reports, which using this pattern here, where we annotate this copywriter state that we defined up here with this injected state class, that's from Langgraph. That allows us to inject the current state of the graph into the tool. And so we're able to actually access the reports by doing that. So all this tool does is print out in a list the current reports in that state research reports attribute. Then we have two specific tools to generate the different content. Here's the LinkedIn example. The blog post is pretty much exactly the same. We have the title and then the content that's going to go into the post, and we're basically just going to write that to a local file in this directory here where we have AI files. So this is the example from the demo. So we're going to save that down to a file locally, and then we're going to return this string message that just tells the agent, okay, the post was generated and then we saved it to this location. And it's the same thing with the blog post. Also, if it's your first time building with these new GPT-5 models, here we're using Mini, you can actually specify the reasoning effort. So this takes in a string which can either be minimal, low, medium, or high. And you'll notice a significant latency increase when you increase to low, medium, or high. Here I have minimal, so this is almost instant. I think it's actually 0 reasoning tokens, if I remember correctly in the API logs. But if you want to make this model slightly more powerful without going up to the next GPT-5, state-of-the-art model, then you can increase this to low or even medium, but that will increase your latency. So everything else is going to be similar to the researcher agent. We're going to have our agent node, the router for tools, and yeah, that's the copywriter. On to the final and most important part of this whole system, which is the supervisor. Let's check out the supervisor system prompt really quick. You'll notice that it is more comprehensive. Spent a little more time on this since this really is the facilitator and the main agent that is going to dictate how good the outcomes are from the overall system. So you really want to spend some time on the supervisor prompt. Obviously, it helps to optimize all of the system prompts, but the supervisor is going to be the slightly more complicated one since we have to add some explanations about the core capabilities, but also break down guidelines for content creation with the copywriter and research tasks when assigning research to the researcher. So we're going to add details about both of those sub-agents and how it should work with them. We have some conversation guidelines outlining the tools. This supervisor only has one tool, which is the handoff tool. And that's just to simplify this example. You can add additional tools to the supervisor. I've built tons of systems where the supervisor can not only hand off, but do a lot on their own. But for this simple example, we're keeping it with just one tool. We also outline the agents and when not to use those agents, which is really important really for any tool description. And then we have some examples of an overall user request and how to complete that request. So this is where we're telling the supervisor that it should always first come up with a plan. And importantly, we're telling it that it can call on the researcher or the copywriter multiple times, basically as many times as it needs to accomplish its task. So if it wants to break out the research into subtopics, then it should call the researcher on each one of those subtopics. and then reminding it here at the end that it should try to keep research tasks focused and atomic. The state for the supervisor is going to have just one more state compared to the researcher and the copywriter, and that's task description. Since the supervisor is the one coming up with the tasks, we're adding this extra attribute for it to keep track of the current task. Here's the handoff tool, and probably the most important part of the supervisor. This handoff tool takes in two arguments. One is the agent name, and by using this literal list, we're telling it that it just has these two options to choose from. In addition to that, it has to specify the task description. And something that we didn't see with the other agents is with this command that we're returning, we're not only going to specify the update dictionary, but we're also going to specify the go-to argument, which again should just be the string name of the next node that we want to go to. So let's start with the update dictionary. We want to update the task description in the state, and then we're also going to, similarly to how we did in the researcher, we're going to append a tool message. Instead of adding data in this tool message, we're simply going to say that we have successfully handed off the task to that agent. Because remember the way that the LLM provider APIs work, anytime you call a tool, we always have to follow it up with a closing tool message to indicate that the tool was successfully called. So that's the update that we're doing. And then we're going to add a prefix here, call underscore, and then the agent name for the next node that we want to go to. Now, because these are the names of the nodes, they have to exactly match the node names that we're actually going to create down here. So we're following the same pattern. This node is called call underscore researcher, and this one is call underscore copywriter. So that's going to be equal to the string that we pass here. So when this tool is called, Langgraph is going to see this command primitive returned. It's going to see this go-to name. And instead of how we normally always go back to the agent after calling a tool, so in this case, it would be going back to the supervisor, we're going to use it more as a routing mechanism to go to an actual node where we're calling the subgraph. So let's take a look at the call researcher node. This is where we're actually invoking the subgraph. So we have a specific node for each subagent in the graph. And so we have to import the compiled graph from these other files. So if we scroll up, we're doing that up here. That compiled graph is what we're invoking here. An important detail about how we're invoking this, here we're going to take the task description from the state and pass it in as a single human message. So as far as the research agent can see, they're only getting this one message. So the research agent is not going to see the full conversation history of the supervisor, right? So this is how we're able to maintain that separate context. And also all of the work that goes on within the research agent graph is going to be independent. So we're going to await this, and once we get the final response here, the research response, we're going to take just the last message from that graph run, create a new AI message with the name researcher, and add that to the conversation history in the supervisor here. So that also means that we're not in the supervisor conversation history, we're not going to get the full conversation history of all the tool calls, the back and forth with the AI in the research graph. We're only going to get the final response, the final output that details the report that was generated. Now, when you get the response from invoking a graph, you actually get the full state back after the run was executed. So because in the research graph, we saved the research reports to the state, we can access it here, and now we can update the research reports state key in the supervisor, and that's how we're able to extract all of the information that we need from the researcher. So hopefully that makes sense. The copywriter is going to work in much the same way, but with one difference where for the input, we're also going to pass in whatever research reports we have in the supervisor's state. So if the supervisor was to call the copywriter before the researcher had a chance to generate its reports, this state key in the supervisor would actually be empty. So there would be no reports. So you kind of have to account for that unpredictability of agents and potentially put that in the copywriter's prompt, where if there are no research reports, it should actually ask this supervisor to run the research first so that it can generate its content. Then once we get back our copywriter response, we're going to do the same thing. We're just going to take the very last message from the copywriter and then append that to the supervisor's conversation history. And you'll notice for the supervisor, it's a slightly more challenging problem to be the supervisor than it is to be the copywriter or the researcher. So here I'm just bumping up the reasoning effort from minimal to now low. That, again, adds a little more latency, but with reasoning, it's going to be a lot better at planning. This is, of course, a really simple example. If you wanted to implement this in a more robust way, you wouldn't rely on the LLM just being able to create a plan and referring to it from the conversation history. You would actually want to give it planning tools where it can create a plan, write it to a file, or save it to the state, and then be able to revisit the plan and check off tasks as it goes. After we define our LLM and when we bind our tools, we're also going to pass this parallel tool call flag and set it to false, because the workflow of the supervisor is actually more sequential for this type of workflow and less parallel. So we don't want it to simultaneously call multiple tools, because that would mean, it would hand off, let's say, 4 research tasks to the researcher and a task to the copywriter. But the problem is that the copywriter needs the research tasks completed. So it can't actually start its work until the researcher has completed its research. So we're disabling parallel tool calling here, but you could design the system where it's more robust for parallelization. Finally, with how we construct the graph, there's a couple of differences between the supervisor and the subagents. Notice here that we're adding the 2 subgraphs as nodes. And down here, we're going to have our normal tool node as well, and the router to catch those tool calls. But we don't actually need this edge to route from the tools back to the supervisor. And that's, again, because in the handoff tool, the only tool that the supervisor has, we're taking care of the routing using the command primitive and telling it what node to go to next, which is not the supervisor. It's either going to be the researcher or the copywriter. So we can actually comment this normal edge out and introduce these additional edges where once a tool is called, that will either eventually go to the researcher or the copywriter. And so we just want to make sure that if we go to either of those nodes, we are then routing back to the supervisor for the supervisor to review the outputs of the subagents and then decide what it wants to do next. If you try to visualize this graph, I'll just execute this. You'll notice that it doesn't get rendered quite right. These 2 subgraphs are separated from the main supervisor graph. It's just a weird quirk of using subgraphs with Langgraph. There is a way to visualize this properly, and to do that, we need to go up here to the supervisor node, and you can uncomment out this piece here where it says destinations. This is a tuple where we're specifying the destinations that the supervisor node can go to. This doesn't impact functionality at all. It's only for visualizing in this graph. So if you want to uncomment that, you also will have to comment out this conditional edge. I know it's really quirky, but you have to do this, otherwise it will get confused. And if we re-render this, you'll see the proper visual representation where we have the supervisor, and when it calls the tool node, we're going to have that command routing either to the call copywriter or call researcher subgraph. We enter the graph, we go through this normal execution, and then go back to the supervisor after. So hopefully it's clear how this design pattern works in Langgraph. If you do have any questions, because I know it was kind of hard for me to wrap my head around the first time, definitely hit me up in the comments and I'll respond. I respond to all the comments. But let's quickly look at one last file, which is main.py. This is how you actually run the agent. So this is the file that I ran for the demo over here. And let me just hit exit here. So if you're at the user prompt, you can just do exit and it'll exit. And you can run it with uv run python main.py. Just make sure that you are in the supervisor directory because that's where the file is. So if you run that in your terminal, then you can get this. But you can also run it in interactive mode by just highlighting all of the code in main.py and then hitting shift enter, and you'll get a printout in your interactive terminal. I'm not going to cover exactly how I built this little CLI tool for interacting with the graph because it's not the focus of this video, but feel free to look at that. That's going to do it for today's video. I hope you guys enjoyed it. I hope you learned something. And as always, thank you so much for watching. If you want to learn more about building AI agents, make sure to check out the AI Launchpad Repo and the other videos on my channel. And I hope to see you in the next one.